Okay, moving on to electric circuits. So electric circuits have a lot more calculations in it, as well as and you will have to learn how to draw electric circuit diagrams, or at least interpret them. So this is in section 1.4 in the notes package. So I have, again, already previously filled in the notes package except for the calculations. So we will do those together. You are going to need your data booklet, a calculator, and then a pen or pencil. Okay, so types of connections. So there are different types of connections that are found within different devices as well as in your home. So the two different types of connections is we have a series connection and we have a parallel connection. So a series connection is talking about a connection in which you have your devices lined up basically in a row to which the electricity or the current has to flow through one device, then the second, then the third, then the fourth, and then eventually going out and then circling back. Now, you could have 3 devices, you could have just 2 devices, you could have 10 devices lined up in a row. Okay, so a series circuit is when electricity flows through one device, then the next in a straight line. A parallel connection is one in which your electricity, your current, is able to flow through multiple paths. So as you can see in this diagram, the input is where your electricity is coming from. So this is where your current is supplied. Okay, so the current is able to flow through multiple paths to get to the different devices or items within your circuit. So this might be a toaster, this might be your fridge, this might be the stove and your dishwasher. Okay, so all of your devices are able to get current at the same time. In this one up here in a series circuit, if you had your fridge and your stove and your dishwasher, actually let's put our stove here first. Say this is your stove, this is your dishwasher, and this is your fridge. Well, if you turn off your stove, that means current can no longer flow through this device, which means it cannot get to your fridge and your dishwasher in order to allow power to them. So this is not very convenient, especially in a home, because you want your fridge, your dishwasher, your stove all working at the same time. So it's not very efficient to have a series connection within houses. But you do have a lot of parallel connections because you want to be able to supply electricity to all of the devices that you are using in your home. So it says circle all the series connections and then box in all of the parallel connections. Okay, so I'm just going to do this. So in my series connections, I need to circle and I need to box in the parallel. So looking at this diagram, this looks kind of Greek. This is what a circuit diagram would actually look like, which I'm going to explain a little bit later. Okay, but this is representing your battery pack. Okay, short line is representing the negative terminal, positive is the long. So I have one battery, I guess you could say, and then another. So electricity is going to flow out the negative like I taught you last time, flow out the negative, and it's going to move to the positive. So it's going to come back around. So on this diagram, we do have series connections and we actually have parallel connections. So if we follow the pathway of electricity, so it's moving this way, electricity can flow through this device and this device at the same time. So right here, we have a parallel connection. When the electricity or the current comes out on the opposite side, it's moving through this device and this device. So these are called resistors, and that's how they're represented in circuit diagrams. But if I'm looking at this example, you have to go through R2 before you can go to R1. So that is representing a series connection because you have to go in order. So that's series, that's parallel. Okay, in this diagram, electricity. So electricity negative terminal, you're going to follow it. It only has one path. So this one is a series connection. Okay, moving on to the next one. So here we have a switch. This is acting as a switch, just like this one. And then you can see that it has the opportunity to switch into both this bulb and this bulb. So it has two paths for electricity to flow. So that is representing a parallel connection. This is just a diagram picture. If I did have you guys in class, this is what I would set up for you, although all of our bulbs are burnt out at this point. But as you can see, electricity is flowing in, and then it has multiple paths to go through. So this whole thing is representing a parallel circuit as well. Okay, so factors that play a role in electricity. So we have voltage. So voltage is the difference in charge, so coulombs, between 2 points. So this is basically the push power behind electrons. Higher voltages basically means you have more power, okay, more pushing power of the electrons. Current is the rate at which electricity is flowing, okay, or that charge is flowing. So how fast is the water flowing, for example. And then resistance is a material's tendency to resist the flow of charge. So how much can you slow down that charge? Okay, so advantages and disadvantages of series and parallel circuits. This is a very important chart, and then when you're going to do calculations, you're going to want to have this handy. So in a series circuit, the advantages is you take your voltage and you can, if you have, sorry, let me go back, let's rewind a bit. If you have your power sources connected in series, then your voltages, you can add them together. So for example, your calculators that you use, your scientific calculators, you're using all 4 batteries at the same time because they're connected in series. Every component will have the same current because there's only one path for the electricity to flow. Disadvantages for connecting in series is you're going to use your voltage very quickly. So this drains batteries very quickly. 2, voltage will be different at each component. So the pushing power decreases if there is more components. So basically it's harder to go through this type of circuit. Parallel circuit. So voltage lasts a very long time because you're only using one power source. Once that is depleted, you will go to the next power source. For this one, every component is the same voltage because you aren't resisting anything. They each all have their own individual path. Disadvantages, voltage is equal, so even if you have 10 batteries lined up in parallel, it doesn't matter. Your circuit is going to use the first one, then the second one, then the third one. And then number 2, current will be different at each component. So this reason is because your current is divided, if it has different pathways, 4 different times or 5 different times, etc. So, example. So, electric service to your home transmits through cables containing 3 wires. 2 of the wires each possess 120 volts, while the third wire is a neutral return wire to complete the circuit. So that third wire we don't really care about. A, to operate appliances that demand 120 volts, describe the circuit that is required. So, if you need 120 volts, okay, and you connected your 2 wires in series, what that means is you would take VT series equals, one wire was 120, the other wire is another 120. So if you added them together, you get 240. So does that work if you only need 120? No. Okay, so you are going to connect in parallel because the total of parallel equals V1, which was 120 volts, equals V2 of 120 volts. So my voltage total should equal 120 volts if I connected them in parallel. Now, if I want 240 volts, you're going to connect it in series, because V total in series equals 120 volts plus 120 volts, which should equal 240 volts. Okay, Ohm's law. You worked with Ohm's law in grade 9, which was quite a while ago, but it's a fairly straightforward calculation. So V equals IR. V stands for voltage measured in volts. I is representing current measured in amps, and resistance is measured in ohms, which is this ohm sign or the lemon sign. If you go to your data booklet, all of these formulas that I'm going to talk about today in this lesson, in this video, are actually posted on page 3. So you can see V equals IR right here, and it tells you the variables, what they mean, and what their correct units are. So before we work with that calculation, there's a couple of things we need to talk about. So I pre-typed this up to make it quicker, and you can pause the video if you're filling in. So resistors. Resistors, basically what they're doing is they're slowing down the electric current. So on a circuit diagram, it's represented by this teeth-looking structure. Now, a resistor can actually be any device. So if you have a light bulb, that actually resists the flow of electricity as well. Okay, so anytime you put a device in a circuit, it's acting as a resistor. Now, we can put resistors in if we do want to slow down the current. So there's an actual thing called resistors that you can put in that do that for that sole purpose. So it says, the next one says, explain the significance of the following diagrams. So I have 3 diagrams here: a single resistor, 3 resistors placed in series, and 3 resistors placed in parallel. So I explain this to the side here. So the single resistor, if you put a resistor, it slows down the flow of current. Okay, so it slows down the traffic. If you place them in, if you place 3 in a series, so one after the other, it slows down the current quite a bit more, because the current or the traffic has to go through the first toll booth, then the second, and then the third. If you connect 3 resistors in parallel, it does slow down traffic a little bit because you do have a resistor, but it's not going to slow it down very much, because these vehicles here, or your current, has 3 options in order to get through to the opposite side. So this one's not going to slow down your current as much. So if you were to compare these 2 in series versus parallel, parallel will be the better way to go, or, well, it depends on what you want the current to do. If you want it to slow down, then you're going to want to connect them in parallel or in series. If you want it to maintain, then you connect your devices in parallel. Okay, so a headlight in an automobile draws a current of 5 amps. So we have 5 amps. So that's representing current, or I, from the car's 12-volt battery. Okay, so that's a voltage. So it says, is the current passing through the headlight AC or DC? So alternating current or direct current. So this is from your previous video on when I talked about motors and generators. So please make sure you watch that. I talked about how the fact that AC current is supplied by anything that's plugged into the wall. DC is battery operated. So it's telling you here you have a battery, so that's DC. Okay, it says determine the resistance, which is R. Okay, so list your variables to the side. R is my question mark. V equals 12.0 volts, and I equals 5.0 amps. So my formula, V equals IR. So now we have to start rearranging equations again. Remember, you always have to do opposite operations when you're trying to rearrange. So in this one, I and R are being multiplied. I need to get R by itself, so I have to do the opposite, which is division. I want to get R by itself, so I want to move I. What I do to one side, I must do to the other. Now, if you have two of the same things on the top and the bottom, they cancel out. So now R is left by itself. So R equals V divided by I. And now you can just plug in your numbers. My V was 12, so I'm just going to put 12.0. You can drop your units, that's fine. And then my I is 5.0. And then you just plug that into your calculator. So 12, whoops, not point. So 12 divided by 5 equals, so I get 2.4. So then I just write 2.4. Now resistance was measured. If you don't know, go grab your data booklet. Find resistance. It's measured in ohms. So I can put my lovely Lululemon sign. Okay, and box in your answer. Okay, next one. A light bulb in a typical lamp is connected to a 120 volt wall outlet. Okay, so we still have 120. That's your voltage. When the bulb is operating, it has a resistance of 240 ohms, so that's R. Is the current passing through the bulb AC or DC? Well, you have to think about what this device is. So it's a lamp, and it's saying it's plugged into the wall. So with it being plugged into the wall, anytime you have anything plugged into the wall, it is representing alternating current, or AC. So B says determine the value of electric current, I, that is passing through the bulb. So I equals question mark, V equals 120 volts, and R equals 240 ohms. So original formula, V equals IR. Okay, highlight. I now want to solve for I because I is my unknown. Okay, so these two are being multiplied. Opposite is divide. I want to divide by what I want to get rid of, which is I. Sorry, which is R. What I do to one side, I do to the other. So now R's cancel out and I is left by itself. And now you just substitute in your numbers. V was 120 volts. Resistance is 240 ohms. And now handy dandy calculator. 120, if you can do this in your head, by all means. You get 0.5. So 0.5, and then current is measured in amps. Bingo, done. Okay, next one, schematic diagrams. Schematic, however you want to say it. So these are sketches that use symbols to represent components within a circuit. I call these circuit diagrams because I don't like the word schematic, but whichever one you want to use. So wire is represented by just the line. Wires joined, you connect with a solid dot. Anytime you have a switch, it's an open dot, and then you'll see that's an open switch, and if it was closed, it would be down. A cell. Now, great thing about this is explaining the difference between a cell and a battery. Okay, so I'm going to see if I can pull up some pictures for you so that you can see what I am referring to. Okay. Okay, this picture, this is a cell. So in science, if I'm drawing this on a schematic diagram, it's represented by this. So a short and a long line. The short line represents the negative terminal, which is this. The long line represents the positive terminal, which is this. Okay, now a battery in science, so we do call these, go to the store, pick up batteries, but you're saying batteries because you're picking up many. So if you have many cells joined together, it is representing a battery. Okay, so in your calculator, okay, I wonder if it'll pop up with some pictures. Scientific calculator. Maybe graphing. Here you go. Perfect. So as you can see here, this is representing 4 cells, 1 battery, because they're all working together. So here you have 4 short lines and 4 long lines. That's representing 4 cells, 1 cell, 2 cell, 3 cell, 4 cell. Okay, and that's very important as well. So a resistor, I've already showed you. A lamp is represented by a squiggly line in a circle. Voltmeter, ammeter, and ohm meter are by the symbols that are used to represent the specific volts, amps, and ohms. So a voltmeter is placed in parallel across 2 points. Ammeter is placed after the component because you want to measure or see what it's actually measuring. And it's directly within the circuit, sorry. And then an ohm meter is placed in parallel across 2 points as well. So voltmeter and ohm meter have to be placed in parallel. Ammeter is placed in series. Sorry. Okay. I'm going to start with B here, and I'll leave the other ones for you to try. I'll do a couple, and then you try, and then check if you've done them right. So in this diagram, it says a single cell, a light bulb, and a switch are placed together in a circuit such that the switch can be opened and closed to turn the light bulb on. Okay, so it says a single cell. So a cell is a long and a short line. Okay, now I have to have a switch and a light bulb. The switch must be placed first because it's controlling your light bulb. Okay, now if I look back up here, a switch is represented by circles that are open. Okay, so I also know, okay, this is a lot of information, that this is the negative terminal, so electrons are going to flow this way. Okay, they're not going to flow this way, and this is important because if you don't draw it right, then it's wrong. Okay, so this is representing my switch, and then you're going to have your light bulb. That's horrible. Let me try that again. Hold on. Okay, so then you're going to have your lamp or your light bulb. So I made a lovely squirrely inside of a circle. And then you just close your circuit. Done. So C says a 3-pack of D cells. Okay, so D cells are a type of battery that you would go buy at the grocery store. So we have 3 of them. Okay, electricity is flowing this way just to help you. I'm just going to do this so that I can figure out what's happening later. Are placed in a circuit to power a flashlight bulb. Okay, it doesn't talk about turning it on and off, so I don't have to put that in. Okay, I don't have to put a switch in. So we just have a light bulb. Could you put your light bulb here or here? Yes, totally. Okay, do A on your own. Try D and E on your own as well. So number 2 says 2 electrical circuits our diagram below. For each circuit, indicate which two devices are connected in series and which two devices are connected in parallel. So we've already done this, so I want you to try this one on your own, and I'll post the answers. Number 3, 3 identical bulbs are connected to a D cell shown at the right, so right here. Which one of the following statements is true? Okay. All 3 bulbs will have the same brightness. Okay. Well, electricity, we got to determine which way electricity is flowing first. That's always what we have to do. It's flowing this way and around. Okay. So when you connect things in series, the first device is going to get the most power, basically, is because it's first. This gets less and less. So they're not going to be all the same brightness. B, the bulb between X and Y. So X and Y will be the brightest. No, that's not true because this one should be the brightest. The bulb between Y and Z will be the brightest. Well, that one doesn't make sense for this to be brighter because these two are closer. So that's telling you right away that D has to be the answer. But it says the bulb between Z and the battery will be the brightest. Yes. Number 4, 3 identical bulbs are connected in a battery to the right. Which of the adjustments could be made that would increase the current being measured at X? So we want to look to increase current there. Again, electricity flowing from negative terminal around. Okay, so this one you can pick more than one answer. So increase the resistance of one of the bulbs. So if you increase the resistance of this bulb, or this bulb, increasing resistance will slow down electricity. So that does not make sense. Increasing the resistance of 2 of the bulbs will make it even worse. Decrease the resistance of 2 bulbs. So if I decrease the resistance here and here, this one should get brighter, which means that you should get more electricity there, or current. So that is true. D, increase the voltage of the battery. Well, if you have more power coming from here, you would have more in the end. Decrease the voltage of the battery. No, that doesn't make sense because from previous. And then F, remove one of the bulbs. Well, if you remove one of the bulbs, then it stops electricity from flowing to the rest, and you will not get any current here. Okay, next calculation. So there's going to be a lot of calculations in this one, and I'm sorry this video is so long. The next one should be relatively, well, a bit shorter. The last 2 sections are the longest. So if you add another bulb into a circuit with only one bulb, you'll have the following results. So in a series circuit, you're going to get dimmer light, and if something happens, it'll also stop working, which I explained in the previous one. So if you're in a series circuit, your total resistance, you add them together. Parallel, you get the same intensity of light because electricity can flow through all pathways, and you use this calculation for resistance if it's in parallel. This is super, super important. A lot of students struggle with this. They just think that they can add. So please make sure that when you're doing your assignments and exams that you know the difference between calculating total resistance for series versus parallel. So a string of lights, small colorful lights, are often used for holiday decorations and other occasions. An inexpensive string of these lights will consist of 8 bulbs connected in series. Each of the resistance in each of the bulbs is set to 64 ohms. Draw a schematic diagram or a circuit diagram for this. Okay, it does not tell me what it's plugged into, but I'm going to assume I'm plugging it into a wall. So when I plug it into a wall, this is representing alternate current of a wall. Okay, I have 8 bulbs connected in series. So there's 1, 2, 3, 4, 5, 6, 7, 8. And then it just comes back. Could I do 4 on this side and 4 on this side? Yes, I'm just not that talented. Okay, so create a circle around all of them to show that they're light bulbs, and there we go. Okay, so the next question is asking, if the set of lights is plugged into a 120 volt wall outlet, so that is representing my voltage. So I'm going to put it off to the side, V equals 120 volts. Okay, determine the current that will flow through. Okay, so I know that I still need R. Well, R's not here, but is there any information up here that tells me what R is? So it says the resistance of each bulb is 64. Okay, since this is series, I'm going to go to my data booklet. And your data booklet is amazing because for resistance connected in series, R total equals R1 plus R2 plus R3 plus R4. Since I have 8 of them, plus R5 plus R6 plus R7 plus R8. Now, to save myself time, I know that I could just go 64 times 8 because each bulb is the same. So I am just going to do this. 8 times 64. Our total is going to equal, so I'm going to take my calculator and go 8 times 64. So I get 512 ohms. So my total resistance is 512 ohms. So just to save you, cross this off because you don't want to work with that anymore. So now V equals IR. I already have V and I already have R. I'm trying to find I. So I need to get I by itself. So divide by R, divide by R. So you'll notice I'll start doing these a lot quicker. So if you need help rearranging, just send me a message on Remind and I can for sure help you the best I can. So 120 volts divided by 512 ohms. You can plug that into your calculator. So 120 divided by 512 equals 0.234. And I'll just keep it to 3 digits. That 3 doesn't tell that 4 to do anything. So 0.234, and since I'm solving for current, amps. C says, use your answer in part A to determine the current that will flow through the third bulb in the string of lights. So this is what this previous table was talking about. So hold on, I just got to find the table. So right here. So I have a series circuit. Okay, this is talking about voltage. Oh, right here it's talking about current. Every component will have the same current because it's one path. So since I have a series, you're going to have the same current here, 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 here. So third bulb should be the same. So since it is series, all components will have the same current. So 0.234 amps. So if the third bulb in the set fails, determine the effect on the others. So they all fail. Okay, because you don't have that connection of the circuit to the rest, it'll not flow through any. And I believe this is our last calculation. A group of students is setting up for high school dance. They work to set up some spotlights and other specialty lighting to help set the mood. 5 lights are plugged into a heavy-duty power strip. Each light has its own outlet. Each spotlight has a resistance of 96 ohms. Explain why the power strip must allow parallel connections to each of the devices. Well, you want to be able to control them separately. You want to be able to turn on and turn off certain spotlights. Separate. Probably spelled that wrong, but whatever. So, draw a schematic diagram. Okay, plugged into the wall. Now, each light bulb, oh, that's bad, sorry, is going to have its own path. So, here is one path. That's one light bulb. Two light bulbs. Sorry, I'm really bad at drawing light bulbs, as you can tell. 3 light bulbs. 4 light bulbs. 5 light bulbs. I'm getting better. 6 light bulbs. Oh, sorry, I'm counting. Woo! Got way ahead of myself. I was thinking 8 from the last one. I only needed 5. Okay, so there's 5 light bulbs. So I just need to finish my light bulbs. Okay, there we go. If the 4th spotlight has 120 volts available to it, determine the voltage to each of the other spotlights. Okay, that was that handy dandy table again. Okay, I'm in parallel. Okay, every component will have the same voltage. Okay, so that means all will have 120 volts because connected in parallel. Okay, determine the amount of current that the power strip requires to power all 5 spotlights. So we're trying to find current. So current is I, so I equals question mark. My voltage was on the previous question of 120 volts. Now my resistance. I have to figure that out. Okay, this is going to require some thought, okay, and math skills. So each bulb is 96 ohms, but they're connected in parallel, not series. So that means I have to use this calculation right here, 1 over RT. Okay, so I'm going to do this up top here just so that you can see it. Okay, and this is to calculate resistance. So I get 1 over RT, which equals 1 over 96 plus 1 over 96 plus 1 over 96. And I've got to do this 5 times. Okay, because I have 5 different spotlights. Okay, when you're adding fractions and all of the bottom number is the same, you can just add the top number. So that's a math skill. So you should have 5 over 96 right now. I still need to get RT by itself. So this is where you would cross, multiply, and divide. So cross. So step 1, you're going to multiply these two. Step 2, you're going to divide that answer. So in your calculator, I'll pull it to this side so that you can actually see what I'm doing. So it's 1 times 96 equals divided by 5 equals. So I get 19.2 ohms. So my total resistance equals 19.2 ohms. So that's what I can write in here. More than likely, I'll ask you a question on this one. So make sure you pay attention. I want to get I by itself, divide by R. I equals V divided by R. So my voltage was 120 divided by 19.2. So 120 divide 19.2, 6.25. So my current is 6.25 amps. Whoops, didn't need to cut that out. Okay, so series circuit versus parallel circuit. So in your house, most of your circuits are actually connected by parallel, so you can manage multiple devices. But in your circuit breaker, so that's that device, usually in your basement, you can flip it and it turns off all the power to your house. That is a series connection because it's allowing you to control all power at once. Good luck.